the first couple of tries are going to be a little rough. I remember just tearing my hair out, but now I can read them in a second. So it's a skill, and you'll get better at it if you practice. But pay attention to the order, and also pay attention to what I point out in each of these slides, because it'll really help you when you do activities down the road in this class. Tests, video reviews, and even your own research studies. So what are research methods, or what's the right way to go about answering this question? And that was the question of the Mozart effect. Well, step one has to do with asking questions. It's formulating logical, testable hypotheses. These are questions with a definite answer. A lot of the things we want to know from science are big, big questions. Why do some boys want to grow up and wear dresses? That's not a testable question. We can't come to any conclusions if we start with that question. I don't even know where it came from, out of somewhere. But we can answer a narrower question, such as babies who listen to music will be smarter than babies who don't. So these are testable hypotheses. And you know that questions with a definite answer is probably a little misleading. They're more like statements that can be proved or disproved. Statements that can be proved or disproved. And a hypothesis is what we base a study around. And to be absolutely honest with you, if you can formulate a good hypothesis, it makes the whole entire rest of your study much, much easier to do. So we'll be giving you a lot of help with the hypotheses until you get the hang of it. So the first tool is formulating logical, testable statements. Second step, and these are iterative with each other, are reviewing the literature. In case of the babies, I might look at a lot of different studies about what kind of music makes you smarter. For example, I might find a couple of other studies about college students, and I might find that listening to Mozart helped students solve math problems better. And I think there is some stuff out there. So I'm going to look at all the information I could find, or I might find something that babies with more enrichment become smarter if people follow them into preschool. And there's a lot of stuff on the 0 to 2 program. There's a lot of evidence for that too. So I'm going to find all of the studies I can that help point me in the right direction of my question. And sometimes I might have to reformulate my question because it has already been answered. But if you're really lucky, it's already been answered in another population or in another way. So you can tweak yours to add to that evidence. So when you review those studies, you will want to know, can you trust them? Are they good quality studies? And that's the kind of stuff you'll learn in this class. After we've got the hypothesis and the lit review under control, we're going to choose our sample. Whom should I study? How do I recruit them? Where can I find them? And most importantly, do they really represent the people I want to know about? So in our example of the babies, a study on babies would be much, much more useful than a study on college students. So if I wanted to find out about babies, who would I recruit? I'd recruit babies, or actually, technically, babies' mothers. But we do, especially when dealing with vulnerable populations such as babies, have to follow some ethical standards. And we'll talk about those in an upcoming lecture. But for now, we've got a tool. We'll learn how to use the tool of choosing a sample. Measurement, and we touched on this as well in the baby study. How should you measure your variables of interest? So in this case, we wanted to know about Mozart in intelligence. So we gave our participants, or the nature study gave their participants a spatial reasoning test. And we've already talked about how that might not have been the best way to operationalize intelligence. And the point of this measurement tool is you have all kinds of options to get at what you want to know. You can do an observation, an interview, give them a questionnaire, or give them a test. And of course, we're going to spend a couple lectures talking about that. Research design. How should your study be conducted? And we're going to go over that as well in a future lecture. But the whole point of a research design is that we want to rule out other explanations. So, for example, if I want to know that babies are smarter if they listen to Mozart, I want to make sure that if the babies that listen to Mozart really are smarter, they're not smarter for some other reason. For example, they might come from homes with higher educated parents. So in that case, I would make sure I would ask all the baby participants, or I wouldn't ask them, I'd ask their mothers, what the level of education in the household is. And I would make sure that the level of education was equally distributed among all the groups. The relaxation group, the sit in silence group, or the Mozart group. I would want to make sure that levels of education were equally balanced among groups so that I could rule out that other explanation. There's lots of techniques for this, but the main point of research design is you want to rule out other explanations. After we gather our data, we will also do statistical tests on them. And this is the part where when I'm live, I kind of look out at the class and students are looking kind of sick to their stomach. I guarantee you, I have never lost a student over statistical testing. In fact, it's really pretty simple. The role that statistical testing plays in a research study, it just lets us know that our results are not due to accident. They're not due to chance. We use statistical tests to help us figure out that our results are not due to chance. They weren't an accident. What we found in our sample is actually what we would find if we had a balanced view of the population to the best of our ability. So it's super simple, and my approach to stats is highly conceptual. So I will not have you do a lot of calculations. I don't think they're really helpful in understanding what stats do. We will just talk about the ways we use stats, the ways we choose stats, and what types of stats are appropriate for which types of questions. So yes, there is a statistical testing component of this class because it's a critical part of research methods, but I guarantee you'll make it through it. And then the last major tool is reporting your results. You want to be very careful about keeping your results from being misinterpreted. You want to write your research article in an objective way and not overgeneralize things. You don't want to make conclusions that are not justified by the data. And you also want to keep all of your evidence, document everything, so if people challenge your results, you can say, look, here, you can do it yourself. You want to write your research article with a degree of detail that anybody reading that article, if they had the same data or if they had followed the same procedures, they could get the exact same results. So there's a lot of detail in it. And I apologize for my dogs. They're wild animals. Okay, so that'll give you an idea of the major tools, and we'll be going through them more or less in order, and they're the ones that you will use in your research papers. So now we turn to one of my favorite parts of this lecture is a research example. And what you're going to do is put your pencils down and close your eyes. You don't have to do it yet. And listen to a list of words that I put forth. You know what? I think I'm going to quiet these dogs and come back for lecture 3. Thank you for your patience. I'll be back in a minute.